Hello everyone, so in this problem, it's quite like the problem number 6, where we're going to rotate an area along some axis. Now, we have this area defined by these three curves. X equals to 0, y equals to 4 over pi, and y equals to tangent x divided by x. Now, we're going to calculate the volume defined by rotating this area along the y-axis. So we see that y is equivalent to 4 over pi, and it is also equivalent to tangent x over x. So on a closer inspection, we can see that x is equivalent to pi over 4. So that tangent x would be equivalent to 1, and 1 over pi over 4 would be just, well, 4 over pi. So anyways, we see that x is from 0 to pi over 4, and now we're rotating it about the y-axis. So now let's take a look. Y is defined as a function of x, and we're going to rotate it about the y-axis. So in the four scenarios we described in problem 6, we see that this is actually scenario number 3. So how do we actually calculate the volume? The volume is, well, in scenario 3, it is the integral of 2 times pi times x times y times dx, and x is from, well, the lower bound to the upper bound. We see that right here, the lower bound is 0 and the upper bound is pi over 4. And we substitute x with, well, just x, and y with, we see that y right here is in fact the difference between the two curves, y equals to 4 over pi, and the other curve, tangent x divided by x. We see that between x from 0 to pi over 4, the value of tangent of x divided by x would be always smaller than pi over 4. So this y right here is actually 4 over pi minus tangent x divided by x. So we can separate this formula into two parts. The first part is the integral of 8x times dx with x from 0 to pi over 4. This term is actually quite straightforward. And the second term, it is minus 2 pi times the integral of tangent x times dx. X is from 0 to pi over 4 as well. So now we can see that this integral can be evaluated to natural log of the absolute value of second x, and x is also from 0 to pi over 4. So the first integral can be evaluated to 4 times x squared, and this would be just pi squared divided by 4. And the second term, well, we have 2 pi times natural log of the absolute value of second x. X is from 0 to pi over 4. When x equals to 0, second x is 0. And then when x equals to pi over 4, natural log of second x will be just natural log of square root of 2. Now we can take this 2 in 2 pi into the natural log, so it becomes natural log of the square root of 2. So the final answer is pi squared divided by 4 minus pi times natural log of 2.